this is the best drivers of the world. I have said that many times, but the best drivers of the world are here at ESOC. And
what we see is the latest images of the comet, as seen from the navigation camera, which starts last Friday, when we started hourly images. And from then onward, we were at a distance of about 1,000 kilometers, and we see very clearly how we get closer and closer. We did more maneuver in the meantime. And the latest image in the sequence is at a distance of about a bit more than 100 kilometers, which is actually from this morning. So this series of images we take for navigating, for computing the maneuver commands, and the start of these images were actually used to compute the maneuver parameters for today.
In the short term, we have a task to do. We want to characterize the nucleus, the comet, the activity, to try and set up and start the process of deciding where to land in November. That's basically the fundamental thing that we're doing at the moment. In addition, we have an activity group. These guys are cometry experts, instrument specialists. They're also backed up by my colleagues here at ESOC, but also the SGS down in ESAC in Madrid, the Science Ground segment, who are helping us, trying to look at how the activity is working at the moment, and then project what we think it's going to be doing after the landing in November. That's important to constrain how the scientific operations are going to be done in that time frame.
Sylvain, say the famous words, please.
We're at the comet! Yes!
Fantastic, congratulations. Andrea, just briefly for a moment, the two of you here right now. You just said you never got it that clearly that Rosetta must be under pressure performing for us. How do you explain such a clear signal? Is that just luck today?
Well, I don't know. We've never seen the temperature of the thruster going so clean and so smoothly as today. So it's a fantastic result. Couldn't have been better. Now let's check the detailed performance of the maneuver offline.
Okay, so Sylvain, you can't go back to sleep now. Now the work begins, correct?
Exactly. And yeah, Rosetta was looking at us, knew that we were looking at her, so this is why she did it for us.
So from imagery, I can confirm we arrived.
So this is the same picture we have on the screen behind us now as well, I think.
Yes, so this is the arrival image of taken by the OSIRIS narrow-angle camera from a good 100 kilometers distance. It came down, it was taken this night. It came down throughout this session, the arrival event today. And you see it as at highest resolution ever, first ever. So the resolution is here, the pixel resolution is 2.5 meters, and you see a lot of detail coming out here. So we see the bright areas, we see the head, we see the depression, and a lot of stuff laid out there. So we see the sides, so the body of the lower body of the nucleus, and a lot of detail. So we see a lot of activity already now, so far out, so far away from the sun. But we can do more. So we process the images. So this is a side view. You reckon this deep 1,000 meters deep depression. And we process the image using RGB image processing. So stretching from the near infrared via the orange band pass into the blue. And you see a lot more detail coming out. So this area, this bright area, is different from compared to the environment. We have another way expressing this in green, so it's very nicely seen by us. So this is a cool area which we might want to link to activity. And here you go. This is really, really fantastic. That far out, see activity coming up, and link it to this source region on our nucleus.
We want to land on this object, so it's not even a car. We are more like an airplane. We have to find a landing strip here. So this is the major task we have in front of us right now. So we are collecting information to get closer to the comet, to increase by a factor 10 the resolution on the surface, to allow Stefan, I think he has left in the meanwhile, to select a landing site. We have to learn how to fly around this object. Olga, where are you? Don't try to ask us to fly through the gorge that we see in the comet. I know you.
It's like a picture being developed. I mean, it goes with the time, it gets more resolution, it gets better, and we learn a lot. For example, today we know now about the temperature and what is the effect. I mean, it's not like comets used to be called as just ice rocks or dirty rocks. Now, this may be more dirty than ice, actually, with more, and this we didn't know. Now we see a lot of things that we will have to see what is the implication of this and how this is this comet came into this configuration.